Hello everyone. In this section, we are going to learn dot product. So we are going to study the definition of dot product and then do some examples. Firstly, we do the calculation and then we will study the application of the dot product and what's the meaning of that. And in 12.5, we are going to do more applications. Okay. So firstly, let's see what is the definition for the dot product. Definition 1. The dot product is the kind of a product between two vectors. The dot product. So we write down this way. We write a dot in between. So we call that u dot v. Okay, of vectors u and v. And the u vector is given by this component u1, u2, u3, and the v vector, which is v1, v2, v3. So the dot product is given by this definition. U dot v equals, we are going to times the corresponding coordinate component. So u1, v1, and the plus u2, v2, plus u3, v3. Okay, this is called the dot product. And here, let's see, the dot product actually is a number, right? Even u and v both are vectors, the dot product is a scalar. O, which is called number. So this is also called the scalar product. Is also called scalar product. Why we want to say this scalar product? Because in 12.4 we will learn cross product. It's kind of different product between two vectors, and that cross product is not scalar product. So we just want to separate those two. Definition, just memorize this formula. How to do the calculation. u1 v1 plus u2 v2 plus u3 v3. Now let's take a look at the example how to calculate dot product between two vectors. So here I just write down two vectors directly. Dot 3, negative 1. So let's see. u1 v1, 2 times 3 plus 4 times negative 1. So just do the calculation. 6 minus 4, which is 2. Scalar, right? It's going to be a number. Now let's take a look at the vector in 3D. Dot 6, 2, negative 1 half. Okay, so this is negative 6 plus 7 times 2, 14, and plus 4 times negative 1 half, which is negative 2. In the future, you can skip the middle step, doesn't matter. So going to be positive 8 minus 2, 6. Now let's take a look at another one. So this vector is given by this way, ijk form. We know this is also vector. So when we write down this way, we have to know for the second vector, there's no I, right? That means for the i's component, it is 0. So when we do the dot product, it's going to be 1 times 0. Just be a little bit careful. 2 times 2 plus negative 3 times negative 1. So the final answer should be 4 plus 3, which is 7. Okay, so here you can try the exercise problem. 1, 2, negative 1, dot 2, negative 3. And I minus j plus 2k. Okay, let's take a look at those two dot products. The solutions are like this. Negative 6 plus 4 plus 3, and 2 plus 3, so it should be 1. Is that right? Yeah, okay. And then next, let's see. This is 1/2 times 4, which is 2, minus 3, and plus 2. So it should be 1. Now let's take a look at the theorem. This theorem gives the equation of the angle between two vectors and the dot product. So let's see what's the relationship. If theta is the angle in between vector u and v, between the vectors u and v, then u dot v equals the length of u times the length of v times cosine theta. So we can also use this as another definition of dot product. And then by using this formula, we can solve for theta, right? So let's see. If we solve for cosine theta, which is u dot v, and divide by the length of u, length of v, and what is theta? Theta actually inverse function of cosine u dot v, length of them. So by using this formula, we can find the angle between two vectors, because we know a vector has direction. For example, if here we have two vectors, u and v, and what is the angle? Right. Now let's take a look at example 2. Find the angle between two vectors. And the two vectors given by this way: I minus 2j minus 2k, and the vector v is 6i plus 3j plus 2k. Okay, so now let's take a look. The cosine theta equals theta equals cosine inverse. We can write down this directly: cosine inverse dot product. Okay, dot product of u dot v, u length, v length, and this equals cosine inverse dot product of uv. We learned this in example 1, so which is u1 v1 should be 6 minus 6 minus 4, and the length of u vector, that is 3, because 1 plus 4 plus 4, root of that is root of 9. And the length of v, we can take a look: 36 plus 9 plus 4, so which is root of 49, which is 7. Now let's simplify. This one equals cosine inverse negative 4 over 21. Okay. And we can just leave the answer like this. Because we don't use calculator, right? Now we can try this. Find the angle between the vector A 2, 2, negative 1, B 5, negative 3, 2. Okay. So A times B dot 10 minus 6 minus 2, 2. And the length of A vector 3, length of B vector 25 plus 9 plus 4, so which is root of 38. So our angle equals cosine inverse 2 over 3 root of 38. Okay, that's the angle. Let's see. Because two vectors, they have angle, so we have another definition is called perpendicular. So perpendicular means if the angle between them is 90 degrees. O power 2. Okay. So in this case, we say those two vectors are perpendicular or orthogonal, power 2. So U vector, V vector. So definition 2. Two non-zero vectors. We cannot have zero vector because for the zero vector, you can see the length will be 0. Then in that case, we cannot find theta, right? And zero vector has no length also. Definition 2. Two non-zero vectors U and V are orthogonal or perpendicular or orthogonal if the angle between them is power 2. Okay, so that's the definition for perpendicular. And then we can see if the angle between them is power 2, and we know cosine power 2 is 0. So the dot product, if they are perpendicular, so it's cosine power 2. So actually dot product equals 0, right? So that means perpendicular, for the perpendicular vectors, their dot product is 0. So let's see, we have definition 3. Vectors U and V are orthogonal if and only if U dot V equals 0. So in the future, whenever we see orthogonal vectors, dot product is 0. Let's take a look at example 3. Show that two vectors are perpendicular. 2i plus 2j minus k is perpendicular to this vector 5i minus 4j plus 2k. So we just need to to look if their dot product is 0 or not, right? So we just do the dot product 2i 2j minus k dot 5i minus 4j plus 2k. Calculate the dot product. So dot product is what equals 10 minus 8 minus 2, and it is 0. So they are perpendicular. Okay. So we can say yes. Next, let's take a look at this one. Zero vector is orthogonal to every vector. So if we say U vector is just like U1, U2, U3, this is in 3D. You can also in ND, doesn't matter too much, n-dimensional. So zero vector, we just calculate the dot product. And do you still remember zero vector? They are all components at 0, right? Dot U1, U2, U3. And this dot product actually equals 0. And because the dot product is 0, so they are orthogonal. Now let's try those two. U vector equals 3i minus 2j plus k. V vector equals 2j plus 4k. Are they orthogonal? Okay, we just want to see if U is orthogonal with V vector. Okay, so we just do the dot product. U dot V equals, for this problem, i's component for V is 0, so it should be 3 times 0 minus 4 plus 4. It is 0, so yes. Okay, orthogonal. Now we have some properties for the vectors. So let's take a look. Properties for the dot product. Okay. The first one, u dot v equals v dot u. So that means we can switch the order of the dot product, because no matter what's the order, that's u1 v1 plus u2 v2, right? It's also, we can write down v1 u1 plus v2 u2. Product, we can switch the order. So here's kind of like proof. Number 2, so we have scalar c times u times dot v, which is, we can do this one. We can do c times u dot v. Okay. Because no matter which one, the final answer will be c u1 v1 plus c u2 v2, c u3 v3. Okay, and then you can just factor c out and prove this one. Number 3, u dot v plus w equals u dot v plus u dot w. Number 4, u dot u. This is pretty important, in the future we are going to use this again. U dot u actually is the length of u and square it. Okay, square. Let's take a look. Why? Because if u equals u1, u2, u3, for example, so u dot u equals what? U dot itself, so it should be u1 squared plus u2 squared plus u3 squared, right? So this is actually the length square. The length is square root of the sum of this thing. So if we take off the square root, square both sides, we get this. In the future, we will use this again. Number 5, 0 dot u, which is 0 dot vector. Okay. And if we say 0 times u, so this means 0. We skip the proofs.